Okay, I'm going to do Leetcode 1732, find the highest altitude. So this problem here, I'm going to just Java. And this is very similar to keeping running sum. You're basically going to add up stuff, but also combined with knowing how to find the highest value in an array. So if you want to visualize this, basically there's a person that's like hiking or doing something like that. They start off at like position at a certain height or like altitude. And then you're given the array gain with all the relative gains or loss in altitude. So if it's negative, that means the person was like, maybe they were started off flat, they went downhill by -5 there. So that's what it means. And then the next element would be +1 from that position previously. So -5 plus 1 would be like -4 here. And then they're now in this position. And then plus the 5 would basically be 1, right? So a little bit above the original. And then 0 means flat, you stay the same. Sorry, my flat is not a great drawing. And then -7 is basically 1 minus 7, it's -6. Think around here. So that's the visualization for this problem. So if you think it's easy for you to understand visually. But basically, you're asked to find, okay, what's the highest I ever got? Obviously, visually, you can see it's 1, right? That's the highest I got. Now let's go through the problem and actually do it. So basically, the approach here is, like I said, you need to know about arrays, an array of a sequence of, in this case, numbers, integer numbers for the gain, and you need to know how to access an element. That's through the square brackets, the position index. That's usually count from 0. And then you can use a loop, like a for loop, to traverse the array from the beginning to the end. You can also use like a helper variable, like int, to keep track of what's the highest value I've seen so far for altitude. But the catch is, how do I know exactly the exact altitude point? Because all the values are relative in gain. So I have to keep track of a running sum. Basically, I have to sum up from 0 and it start adding -5, negative, and then 1, and then 5 to know where exactly I am so far. And then you're going to use that value to compare, okay, how is this the highest we got so far? If so, we're going to take that as the highest point, and then at the end we return. You can see here the return value of the function is just the highest one. So let's go. So we're going to keep track of some sort of sum. So I initialize a variable int sum, value 0. Also, we're going to keep track of the highest so far. So let's call it highest. And I'm going to initialize that. It's safe to initialize to 0 because we start off from 0. So that would be assumed to be the highest I have ever been. So if they just go downhill and stay downhill forever, I still have the highest being the 0 point. And then we're going to traverse the array. And then at the end, we're going to return the largest altitude, which would have been stored in highest. So I can just return highest right after doing a loop here. I'll do for a loop like I did before with the 3 parts traditional. I initialize the variable I integer, 0, semicolon, separate the 3 parts of the loop. And the condition while the loop is going to repeat is while I is less than the size or number of elements of gain. Because it's a primitive array of int in Java, I can just say rain.length like this. And then semicolon, third part is the increment, because I don't want to keep forever at I equals 0, infinite loop. So I need to increase I so that the condition will eventually be false and the loop would stop. So we're going to take gain at I. So gain brackets I gives you access to the current relative gain or loss. And we can add that to the sum that we have so far so that we know what altitude we are so far. So if you take sum and add that and reassign sum, and like I said, some people like doing the plus equals instead and semicolon for the end because it's Java. Okay, so that way we know exactly at every iteration what's the altitude so far. Now we need to find a way, okay, as we're iterating going through the elements, have I seen the highest yet? So we're going to compare, okay, let's see, if that sum is greater than the highest I ever seen, then now the highest will be that sum, which the sum represents the altitude currently, right? So like I start off at 0, like you remember visually, I start at 0 and then go to -5, and then it goes to -4. So as I'm comparing, I'm traversing. Start off this one, the sum is 0, right? And then it goes -5. Okay, it's -5 where I am right now. Is that the highest so far? Obviously, it's not. So far we have seen 0. And then it keeps going. After the 4, it's going to go to 1, right? And at that point, when we are in that 1, it adds to the altitude and it's going to get 1. So 1 is actually highest than the 0 we have seen. Therefore, we're going to reassign the highest to now be 1. And then it keeps going. By the end of it, you're going to get 1 for the highest. Let's go. Return the highest to the point. We got some cases okay. Submit. There you go. As you can see here, same thing like I said before visually. And we got 1 there. The output, which is matching the expected. Now for time complexity, we have to go through n elements of the array of gains. And for that, we have to do the order of n, O of n, time complexity. Space complexity should be constant because I'm not creating any new array. I just have these constant variables. These are variables here which don't take up n space, so just take up, simplifies to O of 1. So, and that's it for this one. Hey, thank you for watching. If you like this content, please consider making a donation so I can keep doing this for you. I'd really appreciate that if you could donate. All right, thank you so much, and I'll see you in the next one.